Hello, in this video we will look at extrapolation. So we will do linearization and then I will show you extrapolation. So the example here is the question of, let's say we want to determine the EMF of a battery and the internal resistance. So that is our experiment. So then how do we do that? So let's first write the equation in the form of y is equal to mx plus c, and then we identify our y x gradient and c, which is the intercept. So let's do that. Okay, so EMF is, we're going to expand that to I big R times I small r. And note that the big R is the external resistance, so that is going to be V external plus I times R internal. So the small r is the internal resistance of the battery, and that IR there is called V internal, or you can say it's lost volts. Okay. So then we want to write our equation in the form of y is equal to mx plus c. So we'll have minus v external. It's equivalent to, I'm going to write, start with r, I. Okay, so I'm already thinking about the y is equal to mx plus c. And the variables I want to determine. So in this form, this means that V external is equal to minus small internal R, internal resistance, I plus EMF. So this is in the form of y is equal to mx plus c, and my y is the external voltage. So this is the form y is called y external, v external, my y, and my gradient is, which is m, is equal to minus r, and then my y-intercept, which is c, is my EMF. And then let me show you what I mean by extrapolation. So you will have your data points, and then as usual you will draw the line of best fit. That's VI. So then when we extrapolate, we will if we have our graph there, then we will extend it until it cuts the y-axis, and then where it cuts our y-axis, that is our EMF. And how do you see that from this equation? Note that when it cuts the y-axis, the V external, so this is y-axis, what you have there is the external voltage. So when it cuts the y-axis, the current is 0, so then the external voltage is equal to the EMF. So that y-intercept there of this graph is your EMF. And from this equation, minus Ri, our gradient is going to be, if you calculate the gradient of this graph, we should get minus R. That is the gradient of this graph there. So now let us proceed with the experiment. So this is our circuit, and I'm not going to show you the EMF. I'm just going to show you that when the voltage is, so the voltmeter reads 15.55 volts, that is the voltage across the battery. The ammeter reads 0.35 amperes, and we have our external resistor here. Note that this battery does have an internal resistance, which is what we want to determine. And then if I open this circuit, you will be able to read the EMF, but I'll do that right at the end. So now let's just take our readings and then put them on the table. So this is, we do the usual process. So how I do it is, so this is how I do it. I keep on changing the resistor. So this resistor is a variable resistor here. So by changing this resistor, I'm basically changing the current of the circuit, and then I measure the voltage. So that's how I control the current. I control it by this resistor here, so that the current now reads 0.65 and the voltmeter reads 15.25. And I put my values on the table here, and then I continue the process. So I'm just going to change the resistance there. The intention of changing the resistance is to control the current. So we can say that the current is my independent variable, and my dependent variable is the voltage, or the external voltage. So when the current is 1.5, the voltmeter reads 14.4 volts, and that is the table there. So what follows now is we going to plot this and then do linear extrapolation. We're gonna do a linear regression, and then we're gonna extrapolate. So here I plotted my points, that is V external on the y-axis, that's my dependent variable, and this is current, which is my independent variable. Remember, when I was changing the resistance, I was actually controlling the current by Ohm's law. So now I have V external versus I. What I will do now is that I've mentioned that the y-intercept is your EMF. So I'm going to do extrapolation, and this doesn't work that way. So let me just remove this, put a line. So you would use your ruler to extrapolate here. And then I just want you to watch. I'm going to extend this line until it cuts the y-axis. So let's just do that. Okay, so it cuts the y-axis just below 16 volts. So that is my EMF. EMF there, it is 15.9 volts. EMF EMF is 15.9 volts. And now I've determined my EMF, so I will go back to the circuit and open it and see if the values agree. In order for me to determine the internal resistance, I'll just have to calculate the gradient, and I'm going to use a table for that. So let me use the table for this. I'm going to use the table values. My gradient is a change of the variable in the y-axis over the change variable in the x-axis. So the y-axis is V, and the x-axis is I. So I'll take the value 15, which corresponds to current 0.9. So 15 minus 15.4, which corresponds to the current 0.5. So when the voltage is 15 volts, okay, right, the 15.4 here, and when the voltage is 15, I have 0.9, and when the voltage is 15.4, I have 0.5. So then the difference is 15 minus 15.4, that's 0.4, and 0.9 minus 0.5, that gives me 0.4. So then V over I is units ohms. So this is my internal resistance. All right, let me actually, that is not, that shouldn't be 0.4, but 0.4, I think should be negative there. So let me just fix that. Let me fix that. Let me redo this. All right, let me just redo that. So I have my gradient, which is delta V over delta I, and then I should have I've selected point 15 minus 15.4. Let me extend this a bit. Okay. Right, let's do that. That is 15.4 divided by 0.9 minus 0.5. So that should be negative 0.4 over 0.4, which is equal to minus 1. And we've said that our gradient, so we said that our gradient is minus r, what we said. So then that means that minus r is equal to our gradient, which is minus 1. So then r is 1 ohm. Okay, so that's how it's done there. And we've seen that the EMF is, we've said that it is 15.9 volts. So let's go to our circuit and verify these values. Okay, so this is our circuit. What can we do to read the EMF? What do you think we should do to get the reading of the EMF? But look at the internal resistance. So if you look at this advanced on the right hand side of the screen, then I have wire resistivity and the battery resistance, and the scale is 0 to 10. So there our internal resistance is indeed 1. Okay, so what about the EMF? What can we do to read the EMF? We should should make this around a second. There we go. Our EMF is 15.90 volts. Right, that's it for the scientific method. Thank you. Any other concepts that more advanced concepts, I will make them in future videos. For now, we will stop here, and then we shall move on to other topics. I think we should do physics equations, and then vectors, and then Newton laws. Thank you very much. Bye.